So this is going to be a short tutorial on the Jupyter Notebook and Python functions. We're going to use the Jupyter Notebook, at least at the beginning of class, to sort of interactively explore Python or learn Python. So from the Cloud9 IDE, you can launch the Jupyter Notebook by simply typing Jupyter Notebook. You should get a prompt that looks something like this, and if you go to click on this link right here, you'll get another prompt, and if you then click Open, it'll launch a new window for the Jupyter Notebook dashboard. So from here, we can then go ahead and open a new notebook by going over here to New. In this case, Python 3 is there. Jupyter is a browser-based, sort of kernel-agnostic front end for computational science, for computing, for interactive exploration. You can have backends that are Julia, MATLAB, R, even C++ in some cases, if you work with a special environment called Cling. But in this class, we're just going to use it for Python primarily, so we'll go ahead and launch the Python kernel, and then we have this sort of notebook interface here. And principally, these cells are places where you can individually execute snippets of Python code. So we can go ahead and write, our famous Hello World program as our first Python program. And then if we execute this cell, and the way you do that is you're going to have to type Shift Enter, so or Shift Return. So if you type Shift Return, you'll see the prompt, and there we wrote our first little program. So we can also do things like 2 + 2, and we get the expected output. We can do floating point arithmetic, so we get something like that. We can do other math features. So if we import a library called math, then we can use math, the sign function that's defined within math library, and get that type of output. One of the neat parts about the Jupyter Notebook is that you can intermingle code, real executable code, plotting, we'll talk about that later, graphics, pictures, other things, with text and equations. So the way we do that is we're going to convert this code cell to actually something called a Markdown cell. So if you go to Cell and Cell Type, and you can then were to change that to Markdown, then you have Markdown is a lightweight markup language that you can do kind of special formatting. So this is a Markdown heading 1. So you have something like that. We can go back up here and show you some of the other headings. And so on. So you have some different headings there. You can have some other sort of textual features. So if you want to make something bold, you use 2 asterisks. If you want to make something italics, you use 1 asterisk. And when you execute the cell, then it formats the text. Okay. So a little more interesting, though, we can do things like we can write code blocks. So if we write 4 backticks, then we could write a code block. So something like 2 + 2. Then it appears in a special different formatting there. If you actually specify a language, then you actually get some syntax highlighting. And if you're just adding 2 + 2, it's not that interesting. But if you do something more interesting, like for example, define a function, which we're going to talk about in a second, within Python. Now again, this is not an executable function. This is just text that's going to be formatted correctly using syntax highlighting. Then you have something like that. Right? Additionally, you can do things like quote text. And then one of my favorite reasons for using this is you can use it to do LaTeX typesetting. So LaTeX is a mathematical, it's a typesetting language that primarily is used for typesetting math equations and other things. We use it to write papers quite often. So you do wrap an equation, and of course you have to know the syntax here, but if you wrap the equation with dollar signs, then you can do things like, so you have a nice formatted math equation. Of course, that's the pressure diffusivity equation that we'll be using in this class. So the nice thing is here is you can intermingle formatted text and equations with your code. So it sort of makes a nice way to create a quick and dirty report, or maybe turn in a homework assignment, because you can explain what the computation is doing clearly in plain text, and then you can actually write out the equations. So the next thing we're going to talk about is functions in Python. And normally when you learn a computing language, you don't learn functions as sort of the first thing, but in this case, all of the code that we're going to write in this class is going to have to be in the form of a function, because we're going to test those functions automatically, and that's how your grade's going to be done. So it's important to sort of understand the basic concepts of functions. So the keyword for a function in Python is def. So like define a function. So for example, if you wanted to define a function called sum that takes two arguments, a and b, then returns the sum of those two arguments, so a plus b, then that's all you'd have to do, and then we can call that function. So we can call it with two arguments, and we get the expected output. And call it with a different two arguments, and we get the expected output. You can also have default arguments in Python. Oops. So you could also have default arguments in Python. So in this case, if I wanted to give b a default value, I would just specify it. So if b is equal to 2, well, if b is not given, then it's automatically equal to 2. And so then I can actually call this function with a single argument. The sum of 2. If I don't specify b, it's automatically 2, so I get 2 plus 2. Again, I get the expected result. You can also have variable arguments. So I'm going to define my sum with a special, this time an asterisk, and I'll have the parameter name will be variable args. And what I'll do there, and we haven't introduced loops yet, but the syntax for loops yet, but I'll go ahead and use a for loop that's going to loop through all the, so variable args will be a list of arguments, and I'm going to loop through them all, each time adding up the contribution. So I have something like that. So again, variable arguments is going to be a list of arguments that I'll put in the parentheses of the sum function, and then for I in the variable arguments, however long it is, I will take on that value and we'll sum them up over the many arguments. So in this case, I could have 1, 2. The output is as expected. 1, 2, 3, 4. Again, as expected. Again, as expected. So that's the keyword, or the variable argument statement. You can also mix fixed arguments, default arguments, and variable arguments in any order. Well, I say in any order. I mean the variable arguments would have to come at the end of a list of fixed arguments. So there's one last type of function, and that's an anonymous function, or a Lambda function. You probably know it as an anonymous function if you come from, say, MATLAB. But this is a kind of an inline or one-line function. So here we can use the keyword lambda x in this case, and then the function x plus 2. So here the argument of the function is x, and then we have x plus 2. So then if we call that function, f of 2, it's going to 2 will be the argument, which will take on the value, x will take on the value of, and then we're going to add 2 also to it. So then you can have lambda functions that are functions of 2 arguments. So in this case, we've just repeated our sum function again. So the last thing is, I'll just explain to you a little bit about how the tests are written so that you kind of get a feel for how your assignments are going to be graded. Any function that you see that has a test in front of it, the word test. So if you see a function that says test, say test, in this case I guess sum, then we use something called assert, an assert parameter, and in this case we're going to assert that the sum of 2 plus 2, right, minus 4, the absolute value of that, which of course if they're just integers that will be exactly 0. But in the case that the arguments were floating point numbers, you could have some very small floating point error from machine to machine, so a lot of times I'll do something like this. Let's say that the absolute value of the difference of the function call, the return value from the function call, and the expected answer is less than some small number, okay? And if you execute that with the assert statement, it's not going to do anything. But if it were to fail when you run the test, then you'll see you'll see the output from the test later. So then the actual way we run the tests is we're going to basically take the Jupyter Notebook and output a Python script, and you can do it directly from. So we haven't given this notebook a name yet, but let's give it a name, my notebook. So now we've saved it. Now you can do things like you can download as a Python script, right? So in this case, if we do this, we'll actually get the raw Python. Now this is gonna download it to my computer, which is not really what I want. So we're not going to run this like this on the Cloud9 IDE. Right? So if I go back here and I go back, there's some other options under download. Like for example, I could download this as a PDF via LaTeX. It turns out they're saying that Pandoc was not installed, which is another something you'd have to install if you wanted to do that. I can show you how if you're interested in that. But you can also download this as a static HTML file. So if you download this as a static HTML file, again, this is downloaded to my computer, but now I should be able to open it. And now you see the same output, but this is not an executable notebook. This is just static HTML that then, of course, you could then print this quite easily as a PDF like that. Okay. So, so then the last thing we'll do, let's just go back, save the notebook one more time, go back to the Cloud IDE. In this case, I'm going to go ahead and kill the notebook server. So the way I do that is hit Control-C twice. So now I have the command prompt back, okay? And there's my notebook, right? So I'm going to use a command called Jupyter NB convert. So Jupyter Notebook convert to Python, and then I'm going to list my notebook, and then I'm going to give the output name as test.py. So I've converted my notebook to raw Python, and if you open that up and look at it, it looks different. You'll see that everything that's not an actual Python statement will just be commented out, right? And so all of the pure Python is there, but all of the Markdown and other stuff that we wrote is just commented out because that Python can't make sense of that stuff, right? So then if I just run the command nose tests, or nose test rather, tests, then it's going to run the test. In this case, the test was the one test, the test sum, and I had the correct answer in there, right? So if we were to go and intentionally foul up the test, right? So say the sum of 2 plus 2 is 4, but the sum of 2 plus 3 is not 4. So this is going to fail the test, and so then you can see what the output is for a failed test. So there's a test failure. So these tests are going to be run automatically from the continuous integration server once you submit the assignment back to GitHub. But this is just to give you an idea about what's going on.